All right, so moving on. Now, what we're going to do next is we're going to look at this format, this form of writing a point. It's not new, it just looks different. So we've got parentheses, just like any other time we write a point. So this is just like when we were writing x, comma, y as a point. But instead of writing x, we're using t as our input variable. And instead of writing y, we're using e of t as our output variable. So this is just like writing x, comma, y, and then we're going to put parentheses around it. So that's why there's these extra parentheses, right? You see a parenthesis, then a parenthesis, because these outside parentheses are just like these right here. Same thing, it's just these parentheses right here that are here on the outside. All right, so don't be afraid of that format. This is just t, comma, e of t is just another way of saying x, comma, y. Input, comma, output. So what does t, comma, e of t mean if t is the input and e of t is the output? So for example, how would you interpret the coordinate pair 6, comma, 90? And if you think about what the input is, the input here represents t-shirts. So we're talking about 6 t-shirts, and we're talking about an output of how much money Marilyn makes if she sells 6 t-shirts. So this is $90. So that's the interpretation that you're writing, that t, comma, e of t, if t is 6 and e of t is 90, just means that when Marilyn sells 6 t-shirts, she'll earn $90. And that this is just a point on the graph, that when the input value is 6, the output value is 90. All right, so I think you're going to enjoy this next part. So down here, what you're doing when it says evaluate, you've done it before. You're just substituting these numbers that are given, 2, 5, and 2.75, into the equation that you wrote before. So I'm going to go out on a limb and imagine that the equation you wrote was e of t equals 15t. Because what that means is that 15t means 15 times t. So for every t-shirt Marilyn sells, to calculate her earnings, we do 15 times that number. So for e of 2 is going to be 15 times 2. So whatever the result of 15 times 2 is, you're going to put in this box right here. And then whatever 15 times 5 is, you're going to calculate e of 5 by calculating 15 times 5. And you're going to calculate e of 2.75 by calculating 15 times 2.75 and putting that result in there. So these are your inputs. These are your inputs, and then you're putting your outputs in these boxes. Then what you're doing is you're going to interpret what that means in terms of the equation, the graph, and the scenario. So if I discover that 15 times 2 is 30, oops, 30, what that means in the equation is that when I substitute 2 for t, my output is 30. What that means on the graph is this is point to 30 on the graph. And what it means in the scenario is when Marilyn sells 2 shirts, she earns $30. So you're going to be doing that in each of these boxes. And you're going to, for these two, you're going to have similar responses, right? And I think I left copy and paste on. So you'll put in your number here. You'll change this number. You'll change this number. Okay. So you'll do your calculations for this one. Same with this situation. But there's something different about this one. And if you think about t-shirts, I bet that you'll realize what's different. Is it possible to sell 2.75 t-shirts, 2 75/100ths of a t-shirt? If someone told you they were going to sell you 2 3/4 of a shirt, what would you say to them, right? So for mentioning the scenario for this case, add on that in reality, right, salespeople don't sell partial shirts, right? For shirts, we only really are going to use integer numbers. We only really have integer inputs. And integers are numbers like 0, 1, 2, 3, right? We don't have partial shirts. So that's a part that you'll have to add for this situation when there's a decimal number that has the 0.75 after the decimal point. Because we don't sell or buy partial t-shirts generally. Then you're going to move down here. So Marilyn has a goal of earning $100 at the festival. So basically, she wants her output to be at least 100. So she wants to make sure that her output is $100, and I bet she wouldn't mind if it was more. But in this situation, we're going to pretend that she wants exactly $100, right? So how many shirts does she need to sell to meet her goal? So what you do, here is your equation. Here's the function that you wrote. And remember, this is the output, and this is the input. So to get $100 out, we want to find out how many shirts does Marilyn have to sell. So that's what they're doing here. They're substituting $100, which is her goal, for the output, and then bring down the rest of your function, your equation, equals 15t, or 15 times t. And now we're solving that equation to find out how many t-shirts she needs to sell. So we're dividing both sides of the equation by 100. We're dividing by 15. So we're dividing 100 by 15, and we're dividing 15t by 15. And the whole reason we're doing that dividing both sides by 15 is that we want t to be by itself, like it is here. And the reason that works is that there's an identity property. So we know that anything divided by itself is 1. So what this allows us to do, if we have 15t and we divide it by 15, these simplify to 1t. And then we know that in algebra, you don't need to put the 1 in front of the variable. If you just write the variable, that means the same thing as 1 being here. So that's why we divide by 15 here, so that we can cancel out these 15s and have 1t, which we just write as t. And if you calculate 100 divided by 15, if you like decimals, you'd get that t equals 6.67, or 6 67/100ths. So to make $100, Marilyn needs to sell 6.67 t-shirts. So really, 6 isn't going to be quite enough. She actually needs to sell at least 7 to hit her goal, right? Because 6 is going to be a little short of $100, and 7 is going to put her over, but the exact amount she would need to sell is 6.67. So that's how they're setting up the equation. So what you're doing here is you're basically writing what I just went over a little bit and what that means. So what does it mean if our t equals 6.67, or t equals 6 67/100ths? What does that mean in this situation? And then also, why can we substitute 100 for e of t? What does the 100 represent here in this situation? And there are drop downs, so you can look at the two situations here and decide which is true. And you can look at your options here. Look at these 3 options and decide which is true.